Good day, statisticians. I just wanted to run through a couple of quick examples of calculating the probabilities based on areas under the standard normal distribution using a table that we call universally Table A. And so here we have, in fact, two parts of Table A. I printed them out on separate pieces of paper because I like bigger fonts myself. But let's talk about doing a couple of these problems. So I have three problems here that I want us to think about real fast. First, we're given that Z is approximately normal with the mean of 0 and a standard deviation of 1. In other words, we're going to be working essentially from this normal curve, right, which has a centered at 0, mean of 0, and we go up 1, 2, 3, 1, 2, 3, standard deviations on either side of the mean. Right? And so in our first problem here, we want to know the probability of randomly selecting a Z from this distribution that's less than 1.65. All right, so if I was to start to do this, I would find 1.65 roughly on this normal curve here, and I'd approximately mark its location. There's 1.65, and I'm going to shade everything to the left of it because it says less than. So let's go here. Oh, look at all this. I'm using this pretty pink marker. Look how shaded and beautiful that is, right? So everything less than 1.65. So that is, because it's a less than percentage, this is, we don't know what this is, but this is a percentile, right? It's the percent of the z-scores that would be less than 1.65. And so that's exactly what our standard normal probability table shows us. Like you see that it's all shaded in to the left of z. So if I want to know what percent is less than 1.65, all I have to do is go here and I need to find 1.65. So I'm going to start by taking 1.65 and breaking it down into 1.6 and then 0.05. So here I've got the positive side. So let's see, there's 1.6 right there. There's 0.05. And so if I can go across just right, it looks like I'm at, I don't know if you can see that, but 0.9505. And so that would tell me that this shaded region is 95.05%, right? Very nice. So that's the area under the curve, and so that would be the probability of me randomly picking a z-score from a normal distribution and getting it less than 1.65. Very nice. All right, so let's do the next one. Z is greater than negative 0.67. So I'm going to draw another normal curve real quick. In fact, we're going to look at two ways of calculating this probability that Z is greater than negative 0.67. All right, and so first let's sketch. I like drawing normal curves. That one was kind of sucky, but whatever. 1, 2, 3, 1, 2, 3. All right, so 0.67 would be, negative 0.67. That would be right about here. Wow, man, this is a sucky drawing. I apologize. But so be it. I'm going to use green this time. And I want, this time, notice I want greater than. So I'm going to shade everything to the right. All right, so how much would this be? Well, method one is we're going to say, all right, if this is negative 0.67, I want everything to the right. Well, one way of finding everything to the right would just be, well, let's find out what's to the left, right? Well, and that's what the standard normal table would tell me. So I could look up negative 0.67 on here, and let's find that. Negative 0.6 is right there. 0.07 is there. Let me go across, and here I have 0.2514. Okay, so that would tell me that this area on this side is 25.14%. Okay, well, if that's 25.14%, then, well, what's this? Huh, of course, that's just 100% minus 25.14%, which is a number. It's, let's see if I can do math. So that would be, what, 74.86%? No calculator. Giddy up, right? So that would be the first method of finding this, saying, okay, if I want everything to the right, let me just find everything to the left and subtract from 100. Method two, well, let's think symmetrically, right? Let's draw this normal curve again, right? And we wanted everything to the right of negative 0.67. Don't you agree that this normal curve is perfectly symmetric? And if it was, what if I was to go up here to positive 0.67 and think, what's to the left of positive 0.67 here, right? Well, wouldn't, oh, my drawing kind of sucks, but wouldn't that just be the same as everything to the right of negative 0.67, everything to the left of positive 0.67? Heck yeah, it would be identical. So if I don't feel like trying to do arithmetic, I can just go to my standard normal table and find positive 0.67. Let's check to see if it works. There's 0.6, there's 0.7, and 0.7486. What? That sounds familiar. Oh, giddy the heck up. It's the exact same answer, right? So everything to the right of negative 0.67 is the same thing as everything to the left of positive 0.67. So we can use symmetry to our advantage. All right, one last question. I want to know the probability of randomly picking a z so that it is greater than negative 0.67 and less than 1.65. Well, I picked things that are related to the stuff I already did. But let's quickly sketch what that would look like here. Let's draw a normal curve. And there's 0, and 1, 2, 3, 1, 2, 3. Okay, so negative 0.67, again, is approximately here. 1.65, there's 1. That's maybe right there. And I'm going to shade that in. I'm going to try yellow this time. Let's see if you can see it. Can you guys see that? Yeah, I can see it. So we want to know what that area is. All right, so this is negative 0.67. This is 1.65. All right, what are we going to do here? Well, let's think. In just a previous problem, I figured out what was everything to the left of 1.65, right? Everything to the left of 1.65 was 95.05%. But now, I don't want everything to the left of 1.65. I want everything to the left, but take away, well, this garbage right there. Well, how do I do that? Well, if you agree that in this problem up here, if I'd just drawn a line at negative 0.67, I could subtract everything to the left of negative 0.67. Now, interestingly enough, how much is that? Huh, I found that right here. So from this problem, I can see that this area to the left of negative 0.67, well, that is 25.14%. And everything to the left of 1.65, remember, was 95.05. So the part in between should simply be 95.05% minus 25.14%, which is a number. 95 minus 25 would be like around 60. Can I do math in my head? Around something, a number? Why am I dumb? But that, my friends, would be our answer. What the heck is, so that's what, 0? That's at 70. I'm so stupid sometimes. So it's a little bit less. It's 69 point something. Man, did I feel stupid there for just a second. Do you guys get the idea? It's very, very beautiful. And this also shows you that you can be pretty good at math and pretty smart, and sometimes you can't remember how to subtract two numbers, so that makes me a little sad. But anyways, giddy the heck up, mathematicians. Life is still beautiful. Hope you're having a beautiful day, and there you go. Adios.